Now we discuss a problem on complex analysis which appeared in a national eligibility test. This problem has appeared in the national eligibility test held on 26th November 2020. It is from the section B. It carries 3 marks and single answer question. There will be only one answer which you have to find out. The problem is coming from complex analysis. The problem is, let P be a positive integer. Consider the closed curve gamma t is equal to e power it 0 less than or equal to t less than 2 pi. Let f be a function holomorphic, that is analytic, in the set of all z such that mod z less than r, where r greater than 1, if f has only one zero at z0, where 0 less than mod z0 less than capital R, and it is of multiplicity q, then 1 by 2 pi I integral taken along gamma f prime z by fz z power p dz equals. The four options are given to you. We have p is a positive integer, gamma t is a closed curve given by e to the power of it 0 less than or equal to t less than 2 pi. It is a circle with center 0 and radius 1. Let f be a function holomorphic. Holomorphic means analytic, regular. In this, it is an open disk. Open disk mod z less than r. That is a circle. That is an open disk with center 0 and radius less than r, where r is greater than 1. If f has a 0, only one 0 at z0, where 0 less than mod z0 less than capital R, and it is of multiplicity q, then 1 by 2 pi I integral taken round gamma f prime z by fz z to the power of dz equals. Solution. We have p is a positive integer and gamma t is equal to e to the power of it 0 less than or equal to t less than 2 pi. What is it? Gamma is the set of all those complex numbers z. Mod z is equal to 1. Mod of e to the power of it is 1. Mod z is equal to 1. A circle, it is a circle with the center at the origin and the radius 1. This is the Argand diagram. This is the origin. And gamma is a set of all z mod z less is equal to 1. It is a circle gamma with the center at the origin and the radius 1. Given that the function fz is holomorphic, that is analytic or regular, in D, the domain which is a disk mod z less than r is an open disk where r greater than 1. So it will be like this. This is your domain D and is an open disk. Clearly, the circle gamma lies inside D. Further, Fz has only one zero Z0 in D, that is 0 less than mod Z0 less than capital R with multiplicity Q. Fz is analytic and it has only one zero at Z0. So therefore, f of z will be written as z minus z0 to the power of q into hz. So that now all the zeros are here, z minus z0 to the power of q. Hz will be analytic in the domain D and h of z0 is not equal to 0 because all the zeros are here and h of z0 is not equal to 0. H of z is analytic in D, and h of z naught is not equal to 0 because since z naught is a 0 of order q which is already there. Now f prime z will be this is the product of two functions. The derivative of the first z minus z naught to the power of q is this into second function h of z into first function z minus z naught to the power of q into derivative of h prime z. Now 1 by 2 pi I integral taken round gamma f prime z by fz into z to the power of p dz is equal to 1 by 2 pi I integral taken round gamma f prime z, this whole thing is here, by f of z is z minus z naught to the power of q into hz into z to the power of p dz. Now separate. Separate means this first term by this and the second term by this. So that will be equal to 1 by 2 pi I integral taken round gamma q times q times q times z to the power of dz by z minus z naught. Why? In the first term, z minus z naught to the power of q minus is there, and in the denominator, z minus z naught to the power of q is there. One z minus z naught remains in the denominator, and hz cancels, and q will be there. Q will be there, and z to the power of p will come. So plus 1 by 2 pi I integral taken round gamma. Now in this z minus z naught to the power of q, z minus z naught to the power of q will cancel, and you are left with z to the power of p into h prime z by h. So that is what you get it. Now this this integral becomes 0. Why? Why? Because integral is taken around gamma where hz is analytic. It has it has only it has no zeros, and sitting in the denominator, it will not contribute any singularities because it doesn't have zeros at all. And h prime z is analytic. So therefore the whole thing is analytic, regular, inside and on gamma. Therefore integral taken around gamma dz is equal to 0 by Cauchy's theorem. So this is by Cauchy's theorem is this. So what is Cauchy's theorem? Let us recall. If f of z is analytic everywhere in a simply connected domain D, this is a simply connected domain D, and C is a simple closed contour lying strictly inside D, then integral taken around C fz dz is equal to 0. This is true for any simple closed contour. For any simple closed contour, this is true. There will be several simple closed contours lying inside D. For all of them, the integral taken around C will be 0. So applying this theorem here, you will get this is equal to 0. So what you are left is 1 by 2 pi I integral taken on gamma f prime z by fz z to the power of p dz is equal to q times 1 by 2 pi I integral taken on gamma z to the power of p by z minus z naught dz. That is the thing what is remaining with us. So we have the brought forward here. Now 0 is less than modulus of z naught less than or greater than 1. Then we have three cases to consider. What are the three cases? Now the question is, where is Z naught? Where is Z naught? So the first case is Z naught lies outside gamma. Maybe. The second case, Z naught lies inside gamma. Okay. And or otherwise, Z naught lies on gamma. Let us take the first case. If Z naught lies outside gamma, so outside gamma, 1 by 2 pi integral taken on gamma f prime z by fz z to the power of p dz is this will be 0 by Cauchy's theorem. Why? Why? Because gamma lies outside. Therefore, z minus z naught will not give any problems. It will not contribute any singularities. It will be regular. This is also regular. Therefore, the whole thing is regular. Therefore, integral taken around gamma will be 0 by Cauchy's theorem, what we have seen in the earlier slide. Now, if z naught lies inside gamma, then 1 by 2 pi integral taken on gamma f prime z by fz into z to the power of p dz is equal to q times 1 by 2 pi integral taken on gamma z to the power of p by z minus z naught dz. And by Cauchy's integral theorem, this will be q times z naught to the power of p. So let's recall Cauchy's integral formula. Let Fz be analytic inside and on a simple closed contour C, and let A be any point inside C. Then f of A is equal to 1 by 2 pi I integral taken on gamma fz by z minus a dz, where C traverses in the positive sense, that is in the anti-clockwise direction. So, it has A is inside the this one. So z minus z naught lies inside gamma. Therefore, your fz is z to the power of p by z minus z naught. So according to the Cauchy's integral formula, it will be f of z naught. F of z naught means f of z is z to the power of p. F of z naught will be z naught to the power of p, and q is constant by Cauchy's integral formula. Now look, if z naught lies on gamma, then the integral is undefined. Therefore, now what the remark what we are making is, this is a question where you are supposed to have only one answer, but you are getting three different cases and three different situations you are getting, and this is all because of your condition 0 less than mod z naught less than r, where r greater than 1. This condition is hampering all the all the all the results. So therefore, what we do is we will modify or revise this hypothesis. Instead of r greater than 1, we take r less than 1. So then we get a unique answer. So instead of r greater than 1, we take r less than 1. Then what happens? Then there will be only one. R is less than 1. R is less than 1. Then z naught lies inside gamma. Z naught lies inside gamma. Only one case will come. And 1 by 2 pi integral taken out gamma f prime z by fz z to the power of p dz is equal to q into z naught to the power of p, as in the case 2. As in the case 2, we get this answer. And the answer is option 1. So that is the modification that we have done in this case. In this case. Now, actually, this comes to the discussion is comes to an end. But I will add, this result can be obtained from a very generalized theorem. Note, generalized argument principle. What is the generalized argument principle? Let fz and gz be analytic inside and on a simple closed curve C, except that f of z has zeros at a1, a2, am. M zeros are there, and n poles b1, b2, bn, and the multiplicities of the zeros are p1, p2, pm respectively, and the multiplicities of the poles is q1, q2, qn respectively. That means b1 is a pole of order q1. That's what it says. And a1 is a zero of order p1. Then in that case, integral 1 by 2 pi I integral taken round C gz into f prime z by fz dz is equal to sigma k is equal to 1 to m pk, that is the multiplicity of the ak into multiplied by the value of g at ak minus sigma k is equal to 1 to n qk, that is the multiplicity of the pole bk multiplied by the value of g at bk. Now, in this case, in the given example to us, we have g of z will be z to the power of p, z to the power of p, and it has only one zero at z naught, that is a1 is equal to z naught of multiplicity q, that is p1 is equal to q, and there are no other zeros and no poles are there. No poles are there. Then your answer will be gz is z to the power of p. It will be sigma will not be there. Only one, that is P1. P1 is Q into G of A1. A1 is Z naught. G is Z naught, Z power P. So it will be Z naught to the power of P. So the answer will come from this theorem as a particular case. But this theorem is very important. It allows many zeros and many poles with their respective multiplicities. and it is that is why it is called generalized argument principle. And the given problem is a particular case of the above. We have fz is analytic with no poles, with only one zero, that is a1 is equal to z0 of multiplicity p1, p1 is equal to q, and g of z is z to the power of p. So then you will get our answer as a particular case. So this is the discussion of the solution of the problem that has come in the national eligibility test, and this is from the complex analysis. I hope that you have understood the solution, and I'm sure you might have liked the solution, and go on working out some more problems in these lines from a standard textbook. I wish you all the best. Thank you.